be putting in work. Commit my life to reverse. Well respected, cause that's my word, and I'm sure you heard. Got a new sound going around. She might have left my hood, but she was born in my town. You didn't know how we was doing on the scene. It's alright, it's alright. I know you never want to see you smiling at me. It's alright, it's alright. Ready or not.
Yo, yo, yo. What's up, guys? Welcome to a terrific Tuesday. Hope you guys able to watch yesterday's video. Get all the information that you needed about the test, and make sure you guys try to get that turned in sometime this week. I have been working on grading. I had a lot, probably like 100 plus assignments, so I'm working on getting that caught up for you guys. Anytime that I receive an assignment from you, I'm always going to reply to let you guys know that I got the assignment. Okay, so if you're still waiting for stuff, just be patient with me so I can try to get most of that stuff done. All right, so today in fact, this week is going to be a pretty easy week for us. We're going to spend a lot of it doing some review on functions. I mentioned that to you yesterday. So we're going to do that now. Hopefully, if you had a chance to watch Chapter 8, the first Algebra Nation video, then you're already a step ahead of everybody. Some of this may be a little bit of a review for some of you, but we kind of want to go over it again. All right, so a function. What is a function? Well, functions are related to graphing. In fact, let me fix these windows here so I can show you. All right, so there we go. I realize that you guys, that the camera's not all that great to pick up the graph whiteboard, but bear with me if you can. So we're talking about functions, and it's intricately related to graphing. All right, so a function typically will say it's an equation, and it will tell us that y equals something. All right, y equals something, and this y equals something is the function. So right here is going to be your equation, and it's going to tell us, this is going to tell us something about x. Because remember, when you're graphing something on a graph paper, you need two coordinates. You need a point on the x coordinate and a point on the y coordinate. So for example, if I had the point 3, 5, right? I go over, this tells me my x coordinate and my y coordinate. So I would go over 3 and up 5, and that would be the point on the graph. All right? Functions tell us where points on the graph go, and it's for us to kind of figure them out. So let's start with the first function that we talked about, which is a linear function. And a linear function is a straight line, okay? Y equals x. That is the basic formula for a linear equation. So what does that tell me? Well, if I have either coordinate, I'm going to know what the other one is because they're both equal. So if someone says, hey, by the way, x equals 3, okay, great. So I'm going to replace this x with 3. And what does that tell me about y? Well, y also equals 3. So in that case, I would go, my x is 3, so I'd go over 3, I'd go up 3, and boom, there it is. Okay? But a lot of times, functions give us kind of this input-output machine. Y equals, and then we have stuff over here that we actually have to do mathematically to figure out what y equals. So I'm going to use a straight line as an example. Let's say that the equation is y equals 2x plus 1. Okay? Now, if we are given x, if we are told, hey, x equals a certain number, let's say x equals 2. So here's what we have to do. We need to put x equals 2 into this machine. Input here, and we're going to input a 2. And what we're going to get out of it, we'll see what we get out of it. What we get out of it is this inside the box here, this machine gives us instructions on what to do with that 2. It tells us that, look, if you put a number in here for x, here's what you need to do. Here's x here. You need to multiply it by 2, and then when you get that answer, you add 1 to it. So I'm going to put in a 2. So this x now becomes 2. 2 times 2 is 4, plus 1 is 5. So if I put a 2 in for x, what I'm going to get out is 5. And this whole thing equals y. So 2 is my x coordinate. I put it into this function. These are the instructions for it. It spits out a 5. Boom. Because y equals whatever the answer to this function is. 5. So if I were to graph that, 2, 5, right there. Every time. All right? So that's kind of the basics of a function, and specifically of a linear function. So a linear function is a straight line. We know that. And there's a couple of things that we need to know about a linear function. So first of all, if you remember, the basic formula for a linear function is y equals mx plus b. Okay? Remember what I said. The standard equation for a linear function is just y equals x. All right? What we're doing here is that they're giving us kind of other instructions or other things to do with our x. So this and this are kind of added. The m and the b are added to my y equals x. I put an m in front here, and I put a b over here. And guys, you should remember from last year and also from early this year that we know m is our slope, and b is our y-intercept. Okay? So if we are graphing this line, we want to figure out what this line is, then we know how to do that. So let's take a look. Let's put in a function again. So I'm going to put in y equals 1/2 x plus 2. Okay? So I have this equation. My instructions to you are, okay, go ahead and graph this equation. You're like, well, I don't know what x is. How am I supposed to graph this equation if I don't know what x is? You create a table. Oops, let me find my eraser here, guys. Let's erase this from yesterday. So I want to know, how do I graph this line? That's my function. How do I graph it? I'm going to create a table. X, y. Okay? So my function was 1/2 x plus 2. Okay? So I'm going to just arbitrarily pick 5 of the smallest numbers possible. 2, 1, 0, -1, -2. And I'm going to plug each one of these into my function. Let's start with 2. 1/2 times 2 is 1. And 1 plus 2 is 3. So when x is 2, if I made that a 2, the outcome, y, remember this is y equals this, is going to be 3. How about 1? Well, 1/2 times 1 is 1/2, and 1/2 plus 2 is 2.5. Okay? What about when x is 0? Well, 1/2 times 0 is 0, and 0 plus 2 is 2. How about when -1? Well, -1 times 1/2 is -1/2, and -1/2 plus 2 is 1.5. And -2 times 1/2 is -1. -1 plus 2 is +1. So now that I've created this table here, I can graph it. It doesn't matter what numbers you pick for x. Pick a handful. I always think it's easier to pick the 5 smallest numbers that we have, which are these 5. Now I can graph it. So it said the first one was when x is 2, y is 3. So x is 2, y is 3. When x is 1, y is 2.5. So 1, 2.5 right here. When x is 0, y is 2. That's our y-intercept. When x is negative 1, oops, let me go back here a little bit. So we're going to end up going to the left. So that's negative 1, negative 2. When x is negative 2, y is 1.5. And when x is negative, when x is negative 1, y is 1.5. When x is negative 2, y is 1. Now I can see my line like that. Okay? So, real quick summary. I'm pretty sure that you guys, I remember when we reviewed this, you guys were really pretty good with this. Okay? So, what do we know about linear equation? We know that it's y equals mx plus b. We also know that when we create a table, I don't care what the linear function is. I used 1/2 x plus 2. We could use a different one. In fact, let me show you a different one. Let's say that I go y equals 3x minus 1. Right? That's different. Let me create the same xy table. And I'm going to go 2, 1, 0, negative 1, negative 2. And let's plug in these numbers for x into this new function up here. 3 times 2 is 6, minus 1 is 5. 1, if I replace x with 1, I get 3 times 1 is 3, minus 1 is 2. 0, 3 times 0 is 0, minus 1 is negative 1. Negative 1 times 3 is negative 3, minus 1 is negative 4. And negative 2 times 3 is negative 6, minus 1 is negative 7. Okay? So we have two examples. This was 1/2 x plus 1. This here is 3x minus 1. Super important that you notice this characteristic. Look at the difference as when x changes, what's happening to y? It is changing by a constant rate here of 1/2. Okay? In this case, we are subtracting 1/2 every time. Every time we go down, we're subtracting 1/2. Every time we go up, we're adding 1/2. So the constant rate of change for this is 1/2. Down here, the constant rate of change is 3. Every time I go down 1, I'm subtracting 3. When I go up 1, I'm adding 3. So 3 is my constant rate of change. We also know that the rate of change for a linear equation, this is known as the slope. So here, 1/2 x minus 1, and down here, 3x minus 1, sorry, this was plus 1. You can see that the rate of change is my slope, and it's the same every time. Every time I go up a number or go down a number, I'm going to be changing by 1/2. Here, the change is by 3. It's constant. So no matter what the x is, my y is going to change by 3. That is the most important thing to remember about a linear equation. There is a constant rate of change. Okay? Now, that's all I want to cover today. I just wanted to quickly remind you guys about what a function is. A function is really just an equation that helps us figure out what our y-coordinate is. When we're given a function, they'll tell us x. They'll say, hey, x equals this. Good, I'm going to put x in here. I'm going to run the numbers, and that's going to tell me what my y is. Then I'm able to graph it. Once I know what x is, I replace x with whatever they tell me, and that will tell me what y is, and then I have a point on which that I can graph. Okay? So for linear equation, y equals mx plus b, you guys are aware of that. And the important thing to remember is that the linear equation, it is always a constant rate of change. The rate of change is the same, adding plus 3 minus 3 plus 1/2 minus 1/2 every single time. The other two functions that we're going to talk about later this week, which are quadratic functions and exponential functions, their rate of change is not constant. Only a straight line is constant. So every time we go up 1, we go up 1/2. We go up again, we go up 1/2. We go up 1, we go up 1/2. We go down 1, we go down a half. That's why it tells us how much we're going up or down. The slope tells us how much I'm going up or down every time I tick x. So when I go up 1, going up 1/2. If this was 3 instead of 1/2, every time I go up 1, I'd go up 3. Go up another 1, go up another 3. Constant rate of change. Okay? So, real simple stuff. That's all we're going to do for today. Guys, I encourage you, if you have not watched Chapter 8, Section 1 in Algebra Nation, please watch it again. Tomorrow we're going to go over quadratic equations, and I might give you a couple of practice problems to do for linear and quadratic equations. All right? So like I said, pretty much a review week this week. Don't forget to get your test turned in whenever you can. Remember, I don't have any time limits, so take your time. Make sure you get it done correctly. And Wednesday I will be on Google Meets at 1 o'clock. And don't forget, make sure you comment on this YouTube video, put your name and your period number so that I can mark you here for attendance. Guys, have a great night. See you tomorrow.